Guys, so today we're going to be looking at properties of rectangles. So rectangles have the same properties of parallelograms because they are a parallelogram. So either side of a rectangle, either pair of sides are going to be parallel to one another. So the top and bottom is parallel and the left and right. Okay, so we have the opposite sides are congruent. So we have that if we're looking at a rectangle over here, okay, let's go ahead and do this. So I'm going to color code them. Opposite sides are congruent. So I'll do the purple's the same as the purple. The light blue's the same as the light blue. Okay. Opposite sides are parallel still, like I mentioned. Opposite angles are congruent. So again, I'll just use the purple and the blue here to show that these two angles, because they're across each other, connected by the same diagonal. And then same blue, I'll just use these two angles are the same. Okay. Consecutive angles are supplementary. So if we pick one blue and one purple, they're going to add to give you 180. And then diagonals bisect each other. So this is half, this is half, this is half, and this is half. Okay? Plus, we actually have two other things. So these are only true with types of rectangles, but we have the all four angles are right angles. Okay, so all four of the interior angles are right angles, 90 degrees. And we also have that the diagonals are congruent. So not only are they cut perfectly in half, each one of these little quarters here is the same. And from S to Q here is the same as from P to R. Okay, so let's go through and look at some of these. So I'll do number one. So we're going to answer QR here. You can see it's going to be the same as the one across from it, so it's going to be 10. SR, if we're looking at it, is going to be the same as the one across from it. So we got 24 there. Okay, we're looking at SQ. However, it doesn't give us the length for either of the diagonals. But if we remember, these are right angles, okay? So we have a right triangle to look at. So if I draw this right triangle the other way, so we have, okay, so if we just do it this way, doesn't matter however it looks, as long as from S to P is 10, and then from P to Q is 24, and the angle S there, sorry, let me try and draw this. So if we, actually let's not draw it out, let's just look at this one, okay? So we have a right triangle, so we can do the Pythagorean theorem, which we're going to be working more with next week, I think. Okay, so the main thing to pay attention when you're doing the Pythagorean theorem is that the one across from the right angle is C. Okay, so we're looking for this side. So we have 10 for A and 10 and 24 for A and B, and then we're not sure what C is. So 100 or 10 squared is 100. 24 squared is 576, and then we have C squared. So we'll have 676 equals C squared, and we're just going to take the square root of both sides in order to get this side that we're missing is whatever you get whenever you put the square root of, let me clear my calculator, 676, and you're going to get 26. Okay, so this SQ, the diagonal that we just solved for here, the whole thing is 26. So I'm going to highlight the whole thing and write 26. So SQ is 26. Now it's asking me PR. You can see that PR is the other entire diagonal, so it's also going to be 26. And then it asks us lastly for QT. So from Q to T is only half of the diagonal, so it's going to be half of 26 or 13. So if you do need help, if you do need to draw the triangle separately, you can just copy it exactly and make sure you do it in the same orientation. That was what I was messing up. Okay. However you want to do it, so you can do it on a different triangle instead of on the rectangle if you want, but just make sure you use the Pythagorean theorem. And that the C is the one directly across from the right angle no matter which way it's going. Okay? So now I want you to take a second and pause the video and try number 2 on your own. Go ahead and try it. Remember to use the Pythagorean theorem when you need. So for instance, we know that this is 15, we know that this is 15, so this whole thing's 30, right? This is 27, and then this one we're not sure about, okay? The 30 is going to have to be the C, though. So you're going to have 27 squared plus we'll call it this one b, equals, sorry, that's a plus sign, a squared plus b squared equals c squared. And you'd have to solve for b there. Okay, so go ahead and try number 2 on your own. Go and pause the video and try number 2. Okay, so now let's go on to number 3, and let's try and look at some angles instead of sides. So here we have that this angle right here is 27 degrees. So in a rectangle, just like how you did in the other ones, if you go down the diagonal, like you trace the diagonal and you go across it, that's going to be the same as well. Okay, and then the main thing to realize, again, each of these are 90 degrees. The entire angle is 90. Okay, so let's look at what we're looking for. So MJK. So M to J to K is the entire angle up here. So we know that's going to be a 90-degree angle. From M to J to L is going to be this part right here. Okay, so the whole thing's 90. 27 is taken up there. That's going to give us what we need for the other one. And so the angle that we're looking for is going to be 63 degrees. Okay, now we're going to be looking at JLK. JLK. So, oops, didn't mean to click that button. So if we look at this one, we can either take 90 and subtract 27 again, or you can say, well, if you're looking at this one, you trace the diagonal and go across the diagonal, it's the same. So it's still going to be 63 degrees. KML. KML. It's the smaller one of the two, so it's going to be the 27. It's going to match with the other ones. This only happens on the rectangles, okay? And then M and L is going to be this one right here. I'm going to do it with 3 of them. Well, we know that this one's 27 degrees and this one's 27 degrees. Since we have this whole triangle here, we know it's going to be 180 minus those two 27s. Okay, so 180 minus 27 minus 27, and that's going to give you 126 degrees for that one. Okay, remember triangle adds to 180, and you should be able to do that. Now, I want you to pause the video and go ahead and try number 4. I will go ahead and start you off by saying these ones are the same. Okay, no matter what, these angles are the same. Okay, I'm going to use a different one. These angles are the same. Okay, I'm going to go ahead and do orange. These ones are the same because they're vertical angles. And then lastly, we have that these angles are the same. Okay, so go ahead and try this on your own now. Go and pause it and try number 4 on your own. Alrighty, so now we're going to look at number 5. And as you can see, I just drew out a second one because it makes it a little confusing when you try and do the sides and the angles on just one. So I'm going to do the sides on the first one. So it gives me that DB is 42. So the entire thing here, this whole diagonal is 42. Okay, and AD, so from top to here, is 26. Okay, and then I'm going to go ahead and label the angle DAE here is 52 degrees. All right, so we need AC. Let's look for AC first. Okay, well, AC is the other diagonal, so it's going to be the same as the other diagonal, so it's going to be 42. EB, if we're looking for EB, it's from here, the center point, to the corner, so it's half of the diagonal, so it's going to be half of 42, which is 21. Now if we're looking for BC, it's going to be this other up and down side, which is going to be the same as the one directly across from it, so it's also going to be 26 long. And then if we look for AB, it's going to be this one, which means we're going to have to do the Pythagorean theorem. So we have this right angle here, and we're just going to make sure that the one across from the right angle here is C. Okay? And this 42 that I have labeled here, I just want to say is for that C. Okay? So we have A squared plus B squared equals C squared. A is going to be this 26. Okay? We don't know what this one is, so we'll label it B. Okay? And C has to be this 42. Make sure you got your squares in there. Okay? So if we go ahead and type in our calculator 26 squared, you're going to get 676, plus we still have this B squared, 42 squared is going to be 1764. So if we need to solve for b, we need to subtract the 676 to the other side, giving us that b squared is going to be equal to, and if you type in 1764 minus 676, that is going to give you that b squared is equal to 1088. And once you take the square root of both sides, it's going to give us a weird decimal number, so we're just going to cut it off at 1 past the decimal. So we're going to have, well, it's 32.98, so if you try and round that up to one place, it's actually just going to be 33. Okay, so this other side here, this AB, is going to be 33. Okay, so now let's look at the angles. Let's go ahead and use what it gives us. I've already written down there, sorry. Angle DAE, so DAE is 52 degrees. Okay, I'm going to go ahead and remember that on a rectangle, that one, the one across from it, those ones are the same. And use a different color for the other ones. These ones are the same. And then you have the angles on the inside here. These two are the same. And I don't usually use yellow, but let's use it. And these two are the same. Okay, so let's go ahead and say all these green ones are 52 degrees. Okay, and we know that each entire corner here is 90 degrees. So in order to find the other angle here, we need 90 minus 52, which is going to give us 38 degrees. So each of these little blue ones are going to be 38 degrees. Sorry. All the blue ones are 38 degrees. Okay. So now, looks like I labeled the wrong one here is what I'm looking at. Okay. So now, if we go to the green, so you draw that. So this is 52 degrees. And then the blue one up here is the 38. Okay. And then if we need the red one, we can just look at any of these, either of these triangles. So if we just split off the bottom triangle, we have two 38-degree angles, and then the angle that we're looking for. So we'd have to take 180 minus 38 minus 38, because there are 180 degrees in a triangle, and then two 38-degree angles take up that, and then the last little bit is 104 degrees. So the red ones there are 104 degrees. And you can either look at the yellow ones as a triangle, like if you took the side triangle like this, the 52 for each of these, and you can subtract 52 from 180 twice. Or, if you look, the way it crosses, the red angle here with the yellow angle make up a straight line. So you can just do 180 minus this 104. Okay? And then when you do that, it's going to give you 76 degrees. So the yellow ones are 76 degrees. Okay, so now let's go through and write in our answer. So it's asking for a measure of angle ADC, so you just gotta match it. ADC, so that's the whole corner, and it's a rectangle, so it's gonna be 90 degrees. Okay, angle ABD from A to B to D, so it's gonna be this angle here. It's 38 degrees, we've got it marked. Okay. Now it's asking us for angle BCA. So from B to C to A, you see here I've got that marked as 52 degrees. And then DEC. So from D to E to C. So it's this red angle here. And we said that one is 104 degrees. Alright, so now we're on the second page and we're looking into some algebra. So again, on a rectangle here, these two sides are the same. Opposite sides are the same. So we know that CD is equal to FE. Okay? Or EF. It's asked for EF on the top, so I'll go ahead and call it EF. It doesn't matter. Okay, so we know that CD is this, so we have this 3x plus 5, and that's equal to EF, so 7x minus 39. Oops, sorry guys. 7x minus 39. Okay, now let's try and solve. I'm going to move the 3x to the other side, and if you're having issues with this part, the solving for x, you need to let me know, and I will send you some videos to watch for that. Okay, minus 39, then we're going to add the 39 to the other side, so we have all the x's on one side, and the other ones, all the ones without x are constants on the other. Give me as 44 equals 4x. I guess x is equal to 11. Okay, but it's not asking us to find out x, it's asking us to find EF, so we need to replace the x and EF for it. So 7 times, instead of x, we're going to write 11 minus 39, so it's going to be 77 minus 39, sorry about that, and it's going to give us 38. Okay, go ahead and try, let's look at this one actually. RT, so from R to T, this whole thing is this 5x minus 14, and then US, the whole thing again, the other way, is 2x plus 10. Those two are the diagonals, and the diagonals are equal. So we have the RT is equal to US. Okay, I want you to use these and try and solve for x. So you're going to go down till you get x equals some answer, and then after that, it's asking for VT, and that's going to be half the measure of one of those. So we'll just go ahead and do half the measure of 2 times whatever you get plus 10, because from B to T is only half the diagonal. Okay, so go ahead and try that out on your own. Go and pause the video now and try it. Alrighty, so now let's look over at number 8. Okay, so JM, so this part right here, is x plus 17. And then MK, so this half, the other one, is this 5x minus 23. Since they're both just half of a diagonal, they're the same. So again, we have JM is equal to MK. Okay, let's replace these. So we know that JM is x plus 17. We know that MK is 5x minus 23. I'll move the x to the other side first. Then we'll add the 23 to the other side. Okay, then you get 17 plus 23 is going to give you that 40 equals 4x. And then we can divide by 4 just to give us that x is equal to 10. Okay, but again, it's not asking us for x, it's asking for JL. Okay, so JL is the entire diagonal, so it's going to be 2 double half the diagonal. So instead of x plus 17, we'll do 10 plus 17. Okay, so it's 2 times 27, which should give you 54. Okay, looking at number 9 now. If VW, so half the diagonal here, is equal to 9x minus 11, and SU, so that's the entire diagonal, is 16x minus 12. Sorry, I keep pushing the button with my thumb. Okay, so we know that SU is going to be equal to double VW. Sorry, I started writing it out. VW. Because VW is half of the diagonal, and SU is the entire diagonal. So now let's go ahead and go through and fill in these blanks. So SU is 16x minus 12, and then VW is 9x minus 11. Okay, I want you to distribute the 2. Go ahead and go down till you solve for x. Okay, and then it asks us for WT, and WT is going to be, again, half of a diagonal, so we can go ahead and use the VW. So we'll do 9 times whatever you got for x minus 11. And type that in your calculator and see what you get. Okay, so we just know that half the diagonal is going to literally be half of the diagonal. So if we have the half diagonal and the diagonal, you just have to double the little half in order to get the whole. Okay, now we're looking at angles. Okay, remember, if they look like they're the same, they're the same. So these angles are the same, which means these two are equal. Okay, so this 7x plus 5 is going to be equal to the 11x minus 3. Let's go ahead and solve for that, for x. Minus 5 equals 4x minus 3. I'll add, sorry, I didn't mean to add 5. We're adding 3. I keep pushing buttons, you guys. Okay, add 3 to both sides. Gives us 8 equals 4x. Divide by 4. Gives us that x is equal to 2. But again, it's asking us for a measure of angle BCE. BCE is the other angle, so it's going to be 90 minus whatever 11 times 2 minus 3 is. Okay, so if we do the 11 times 2 minus 3, we're going to get 19. So 90 minus 19 is going to give us 71 degrees. Okay? So again, just mark the ones that are the same. Like this one. You know that these ones are the same, because you can see they're smaller than the other ones. And I'll do a different color. You know that these ones are the same. You can see that these two, the two that we're looking at here, okay, they add to this 90-degree angle. So you're literally going to do one of them plus the other equals 90, because they add to 90 degrees. Go ahead and fill those in, so like literally have the 3x plus 2, and then the 12x minus 17. Okay, and now I want you to go through, try and solve for x, and then try and figure out what the measure of angle JHI is. Okay? Go ahead and try that on your own. Go and pause the video and try and finish that one. Okay, so looking at this one, we're going to do the same thing. Again, these ones are the same. The small ones are the same as all the small ones there. And then the big ones are the same as all the big ones. Okay, so the larger angles, all the same. And remember, they're all going to add. So any pair of black and blue here are going to add to 90. So we're going to have blank plus blank equals 90, because we have a black one and a blue one here highlighted. So we have this black one is x plus 20, and the other one is 5x minus 8. Okay, so again, go ahead and solve for x, and then go ahead and try and figure out what the measure of angle XZW is from that. Okay, so go and pause the video and try and finish that one. And now, lastly, I'll go ahead and look at this one. So, we again know that these ones are the same. We know that these ones are the same. I'm actually going to show you how to set this one up, because it is kind of a lot. Okay, and we know that these ones are the same. Okay, so we can figure out what the black angles are because we have that. But we do not have anything for the red angles. Or sorry, I am apparently colorblind, the blue angles that I have marked here. But we do know that they're going to be 90 minus this 5x plus 7. Okay? And so we know that each of these are 90 minus this 5x plus 7. Okay? So if we look at this triangle here, we can solve for x using that. So we have this triangle. I'm going to draw it up here just out so you can see it a little better. So we have, this one is 134. This one's 90 minus 5x plus 7. And this one's 90 minus 5x plus 7. Okay? So that's going to add to 180. So we have the 134. And then instead of trying to add them all together like that, we're just going to multiply it by 2 because it's the same thing. Okay? And that's going to give us 180 when you add them all together. So I'm going to go ahead and simplify this a little bit. Okay, now we're going to so I distributed this 2 to both of those factors, and now we're going to distribute this 2 to this negative 2 to those factors. So we have 134, that's still equal to 180, sorry about that, plus 180 minus 10x, and then negative 2 times positive 7 is going to be negative 14 equals 180. Let's go and see how many x's we got. Looks like we only have this negative 10x. Then we have 134 plus 180 plus this negative 14. Okay, and that's going to give us plus 300 is equal to 180. Okay, so we can subtract 300 from both sides to try and solve for x, giving us negative 10x is equal to 180 minus 300 will give you negative 120. And then we can divide by negative 10 to give us that x is equal to 12. Okay, so let me know if you guys have any questions about this. The main thing to focus on these is that if you have a rectangle, remember these things on the top. Opposite sides are congruent, opposite sides are parallel, opposite angles, are congruent, and consecutive angles are supplementary, so ones that are right after another, not directly across from each other. The diagonals bisect each other, so all 4 of the diagonal pieces are the same. And then also that all 4 angles are right angles. So again, let me know if you guys have any questions on this or you have any problems. Get it finished and then go on to the practice problems. Have a good day, you guys.